Hey guys, so welcome to Wednesday. We are determining the number of roots that a quadratic equation has. So think in your head, again, what's another name for root? If you said solution, x-intercept, or zeros, right? Because these are where the y is equal to 0. You can even put that in your calculator to find the intersection point on the graph. So those are the four names. So roots, solutions, x-intercept, zeros, and we're all solving for the x value in a quadratic function when y is 0. Okay, so here they gave you three quadratic functions, and they wanted you to match it with the graphs on your worksheet. So make sure that you have your worksheet because I don't have the graphs on here, but I am going to refer to them. All right, so in equation 1, remember that this plus minus means that I can have x equals -6 plus square root 8 divided by 2, and x equals -6 minus square root 8 divided by 2. And I'm actually just going to use my calculator to do square root of 2. Not square root of 2, square root of 8. And square root of 8, I'm just going to write it up here, is about, right, squiggly equals, about 2.8 if I'm rounding to the nearest tenth. So I'm just going to replace the square root of 8 with 2.8. And that will give me an approximate value for my roots. So -6 minus 2.8. And let me not forget to divide them both by 2. Okay, so -6 plus 2.8. Feel free to do this along with me or pause me while you figure it out. Is x is equal to -3.2 divided by 2, which is -1.6. So that's one of my roots. And then I have -6 minus 2.8, which is -8.8 divided by 2 is -4.4. So there's my second root. So because I have 2 roots, that would be graph number 3. Because I see in graph number 3, it looks something kind of like that. Excuse my rough estimate, because it hits it in 2 places, and they're both on the negative side. My sketch doesn't look that great, but if you look at graph number 3, that's such a messy 3, sorry. If you look at graph number 3, you will see there a little bit more clearly than what I've drawn, that the quadratic hits the x-axis at 2 different places, just like we have 2 different roots. Okay, so equation 1 goes with graph number 3. All right, so equation number 2, this looks like it's factored. So you can either use zero product property here, or if you wanted to do a complete the square, it's already given to you. This is already a perfect square trinomial. So you could write it as x plus 3 squared and then take the square root. So both of them seem fairly easy to me. So I'm just going to use zero product property. I'll treat it as a factor. So I have x plus 3 equals 0. And another x plus 3 equals 0. Okay, so now I'm just going to solve here. X equals -3. And again, I have x equals -3. if you notice, these guys are the same number, right? So that means that when I have the graph, right, when I have my x-axis at -3, that is the only place the parabola is going to get to that x-axis. So this only has one root, right? So this only has one solution or one root. Whereas this one had two roots, right? Or two solutions. Okay, so for equation number 2, that would be graph number 2. So graph number 2. Cool. So equation 2 goes with graph number 2. Okay, so equation number 3, that would obviously go with graph number 1. And graph number 1, oh, that is so messy. Sorry, guys. All right, graph number 1, it has a parabola like this. And if you notice, it doesn't even touch the x-axis. So this is no solution. And let me put no real solution. Right? I've got no value for x. And if you put square root of -12 into your calculator, and in fact, I'm going to do that, right? Just like I turned the other one into a decimal, I'm going to put square root of -12 in my calculator. And when I did that, when I put square root of -12, it told me error. And if you read your error notification, it says non-real answers. So this goes back to the very beginning of the year where we had real numbers, right? Or not real numbers. Real numbers. And this gets into imaginary numbers. So you're going to talk about that a lot in Algebra 2. But for our purposes, these numbers don't exist. They can't give me an answer. So anytime you have a negative inside that square root, it's not going to touch the x-axis. You're not going to have any answer you can put in for x. All right, and that is actually kind of our lesson today. So we're talking about something called the discriminant. And it's a big fancy word, but it just means this part of the quadratic formula. So remember, quadratic formula, you can always look up. It will always be given to you on any test. At least as of now, the Regents always gives it. And it is -b plus or minus the square root of b squared minus 4ac, divided by 2a. So the discriminant is specifically this inside part. And it's just saying that if this part, if b squared plus 4ac, if that's a positive number, right? So remember, if the d, right, they're saying d is what they're using to show discriminant. If that's greater than 0, which means a positive number, 1, 2, 3, 4, 5. If it's a positive number that's greater than 0, then it's going to give you 2 solutions. All right, just like in my first example in this one, right? It was a positive 8, and it gave me 2 solutions. Okay, if that discriminant is 0, it will only give you 1 solution. And we're going to go over an example of that. And again, if this discriminant part, right, this b squared minus 4ac, and remember, I don't square root it, right? The discriminant is just what's inside of the square root. If that is less than 0, meaning it would be a negative discriminant, then there would be no solutions, 0 solutions. And we saw that here, right? Because we have a negative discriminant, it's a negative 12. And so when it's negative, no real solutions. And that's basically the lesson. So I'm going to go over the first one in each of kind of like that second section that you have. And I'm just going to repeat kind of what I've said. So here, it's important that we have the entire quadratic function on one side and a 0 on the other. So if that is not the case, you need to do that before you can do quadratic formula. All right, so again, I have x equals, I'm just going to rewrite the quadratic formula. Okay. Remember to always keep your square root so that it really covers everything underneath it. All right, so 2a. Okay. So I'm just going to replace a, b, and c. So remember, a is always the term in front of the x squared. So a would be 2. B is always in front of the x, so that would be 7. And c is always the constant or the number by itself. And so that is also 7, right? The constant would be right there. Okay, so now let me fill in. So I've got, oops, let me not forget my negative there. All right, so I've got negative, well, let me erase all the b's. All right. So instead of b, I'm going to put in 7. So negative 7 plus or minus the square root of 7 squared. Now let me replace a with 2. Okay, and I'm going to replace c with this 7 down here. Okay, so in order to find out if it has solutions or no solutions, I'm really just focusing in on what's inside the square root, which again is my discriminant. And, okay, so can you see what that reduces to? All right. It simplifies to this square root of negative 7. So in this case, the d value is negative 7. And remember, if the d value is less than 0, if it's negative, that means it has no solutions. So your answer there would be no real solutions. It would be a non-real number. Okay, so good. Anytime there's a negative inside the square root, no solution. And don't take your math for it. Like if you forget, plug it into the calculator, right? Put your quadratic function, right? So you can just put y equals 2x squared minus 4x plus 2 and see how many times it hits the x-axis. So if it doesn't, no solution. If it does, 1 and or 2. You know, those are your 3 options. All right. So again, they have plugged in all of these numbers here. So I'm just going to check their work. So A is 2. B is negative 4. And C is this last constant 2. Cool. So every time they had B, I see that they did put in a negative 4 here. Cool. All right. Every time they had an A, remember this guy was an A, and this one over here was an A. Good. They put in 2. And then here they put in C. Cool. So they put in everything they needed to. So now I'm just going to reduce that over here. Let me do that in red. X equals, A negative 4 becomes a positive 4. Plus or minus, and this is where it gets important, right? This is the discriminant right here. All right, and I need to use my calculator. Actually, maybe I could have done that in my head. All right, so parentheses, negative 4 squared minus 4, parentheses, 2, and another parentheses, 2, right? So I'm just going to do that down here so it's super clear, right? The discriminant is just what's inside. It's not the square root of it. It's just this part. Negative 4 squared minus 4 times 2 times 2. And when I put that in my calculator, I get 0. All right, so that is 0 divided by 2 times 2 gives me 4. All right, so remember, if it's 0, if the d value equals 0, then it's only one solution, one root. So if I looked at the graph, and I actually don't know where it hits the x-axis, but it should only hit it once. And actually, let me do that. So the square root of 0 here, the square root of 0 is 0. You can put that in your calculator. Put square root of 0, and it will give you 0. Remember, 0 times 0 is 0. All right, so here I would have 4. 4 plus 0 is 4, and 4 minus 0 is 4, right? So 4 plus 0 divided by 4 gives me 4 divided by 4, or 1. So that's one of my solutions. And 4 minus 0, let me put a little, okay, divided by 4. 4 minus 0 is 4, and 4 divided by 4 is still 1, right? So where x is 1, that is the only place, the only solution where this quadratic is going to cross the x-axis. All right. So cool. So anytime your discriminant is 0, it's only going to hit the x-axis one time. All right. And here, it looks like it's going to give us two solutions. Even before doing anything, I can look, the discriminant is a positive 49. Remember, anytime the discriminant is greater than 0, you're going to get yourself two solutions. All right, but let's do the math to check it out. So here, a is negative 2, always the number in front of x squared. B is 7, always the number in front of x. And C is the number by itself. But I don't see a C. I don't see a constant. So if you don't have that term, then that's a 0, right? If I didn't have an x term in the middle, then I wouldn't have a b value. B would be 0. So I have an x term, so b is 7. I have an x squared term, so a is negative 2. Let me make that clear. But I don't have a number by itself, so that's 0. All right. So now I have negative b plus or minus. Okay, 2a. So every time I see a b, I'm going to replace it with a 7. So b, okay. So 7, 7. And that's a squared. Okay. All right. Now every time I see an a, I'm going to replace it with a negative 2. And I kind of already erased my C, but my C is right here, okay? And I am going to replace that with a 0, okay? And just keep that square root. Oops, that is a horrible looking 0. Okay, so again, my discriminant is 7 squared minus 4 times negative 2. And let me just do this in my head. All right, so 7 squared is 49. Negative 4 times negative 2 is positive 8 times 0. 8 times 0 is 0. So I actually have 49 plus 0, which is just 49. All right, so that's how they got that number there. So remember, if the D is positive, the discriminant is positive, I've got myself 2 solutions. So let's see. Let me erase a little bit of this. Sorry, guys. I hate erasing it. I know that it's nice to see the work, but go back and, copy down any notes that you need to. That's the nice thing about the pause here. Okay, so I should be getting 2 values of x here because I know that that discriminant is positive. So I have negative 7 plus or minus. Square root of 49 is 7, right? Remember, 7 times 7 is 49, divided by negative 4. All right, so I'm going to have x equals negative 7 plus 7 divided by negative 4, and x equals negative 7 minus 7 divided by negative 4. All right, so this would give me x equals negative 7 plus 7 is 0, divided by negative 4 would still give me 0. So one of my roots is 0. And the other root, negative 7 minus 7, is negative 14 divided by 4. All right, so negative 14 divided by negative 4 gives me a positive 3.5. All right, so when you graph it at 0, and in between your 3 and your 4, right smack in the middle, you should see the other root, which again is so much more sloppy if I'm writing it. So your quadratic should go through the x-axis at 0 and at 3.5. Luckily, you don't have to graph that. You just have to look at the discriminant and say, is it positive? Cool, 2 solutions. Is it negative? Cool, no solutions. And is it 0? Cool, 1 solution. Okay, so really I'm doing a lot more work than you had to do on your worksheet, but it is always good to check your work and not just plug it into a formula, but really take the time to understand why it's working like that, and that will help you remember it better. All right, so questions, comments, or concerns, talk to each other, reach out to us, give yourself time to struggle. Remember, Friday is the last day of this marking period. Please, please, please reach out to us if you need anything. Next week also is your test on Unit 5. So please be keeping up with the work so it's not the day before the test and you're trying to study the entire unit. That just never works out well for anybody. Okay, good luck, and I will see you at the next lesson.